All right, let's talk about cyclic groups. Talk about elements. So if you have a group and you have an element of infinite order, the only way two powers are going to be equal if is if. On the other hand, if you have a finite order, then the order g is equal to that, and basically get so gi equals gj if and only if when you subtract I and j, they differ by they're equal to 0 mod n. So I minus j equivalent to 0 mod n really means that I is equal to j plus some multiple of n. So they're almost the same, except they just differ by a multiple of n. All right, so first suppose we have an infinite order and that they're equal. Well, what we can do, we can just do a little bit of stuff. I can multiply both sides by I have gi equal to gj. I can multiply both sides by g negative j, in other words, gj inverse. And that amounts to using laws of exponents. I minus j is going to equal the identity. And that's just what we have right there. So I minus j equals 0, in other words, because that's the only way to get the identity out of there, and I is equal to j. And of course, if I is equal to j, we can go the other way. If I is equal to j, if we start with this, then this is going to be true trivially. So we should actually write that down, and I just said it verbally, but that's fine. So we just need to look at the finite case. If g is finite of order n, well, we're first going to prove that the order g is equal to this. Or not the order g, the subgroup generated by g is equal to just a bunch of different powers of g, and there are only n of them. So by definition, this is what the subgroup generated by g is equal to. So I'm going to prove that this thing here equals that thing there. Basically means we're going to get a lot of repetition. So, I mean, clearly, this thing here is a subset. So I just that it goes the other way. That all these powers get scrunched down into just these n things. And that is far from obvious. But we're going to prove it. So I'm going to let g sub k be in here. I'm going to prove that it has to be between, that's equal to something, gk equals g sub l, where l is between 0 and n minus 1. That's what I'm going to prove. Take a look. Positive, negative, or 0. So I'm going to use the division algorithm. The division algorithm tells me that I can rewrite k is equal to qn plus r. So then is equal to g qn plus r, which equals that, But remember, n is the order of g. That is going to give me the identity, g sub r. So g sub k is equal to g. But g sub r, remember, r is between 0 and n, non-inclusive. So that's right in here. So g sub k is equal to g sub r, and g sub r is clearly in there. So we're done with this. That's great. So we get that we have g is a subset, and that gives me equality here. Great. So now we're going to show the last part, that if the order is n, then if you get two powers that are the same, that means they differ, that I minus j is equivalent to 0 mod j, just differ by multiple inverses. Well, you can multiply by inverses as I did in the first page to get the identity, and you can use the division algorithm to get, you're going to use the division algorithm on I minus j, and you're going to get qn plus r for the same conditions. But then the I is equal to g to the I minus j, which equals g to the qn plus r. Just a little switcheroo like that, and now g to the n is the identity, because that the identity equals g to the r. Well, if r has between there and there and there, r has to equal 0. So because r is equal to 0, that tells me that I minus j is a multiple. But that tells me that if I mod out by n on both sides, this becomes 0, and I get I minus j is equivalent to 0 mod n. So now I'm going to suppose the other way. Now suppose that I minus j is equivalent to 0 mod n, then that's going to be true, because that's what it means to be 0 mod n. I'm going to just do this so everything works out. So this is q to the end of the q, but g to the n is the identity because, so g to the I minus j. And that means that what I can do is I get g to the I times g to the negative j. And then what I can do is I can just multiply both sides, I guess on this side g to the j, g to the j. That's going to give me g to the j, and that's going to give me g to the I. So g to the I equals g to the j, just like I wanted. And that's it. We're done.